let's look at problems that you may encounter that have you use the energy budget for the photoelectric effect. Now, you're only going to use this in problems that talk about photoelectrons or shining light on metal. So there'll be a lot of problems that don't involve the photoelectric effect at all. This is specific for this kind of situation. And what you're trying to do usually is relate the energy of a photon with the energy of the photoelectron that comes out, and the threshold energy. This is the energy that is required to pull an electron out of the metal. Now, you can calculate, you can either be given or be asked to calculate these things in different ways. We know that the energy of the photon is equal to Planck's constant times the frequency. So if they give you a frequency, you can calculate a photon just by multiplying Planck's constant times the frequency they give you. What if they gave you a wavelength? You could calculate the frequency there by taking the wavelength that they give you, and the frequency is really equal to c over the wavelength that they give you. This is not happening. C over the wavelength that they give you. So they could give you all kinds of things to have you get the photon energy. They could give you the frequency. They could give you the wavelength. If they gave you the wavelength, you'd have to use your relationship that we've used already to find the frequency, and then take the frequency times Planck's constant, and figure out the photon energy from that. So there's this chain. Now we're going to be following this chain, doing a lot of examples of this kind of calculation, where we're going to take a wavelength and calculate a photon energy. We're going to do a lot of that in the next worksheet, so I'm not going to go through that right now. But this is just kind of a look ahead. You need to have this relationship in your head and this one. You should know those. Now, the energy of the photoelectron, usually they'll just give you a number for that. But if they don't, you have to know that that's a kinetic energy. And this m here is the mass of the electron. And this v is the speed of the electron, the photoelectron. And if they give you these things, if they give you a speed or something, you can calculate that. But usually they're going to just give you that number. And usually they're going to either ask for the threshold energy, they're going to want you to calculate it, or they'll give it to you in the problem. So let's do a sample problem that uses this energy budget. Suppose I tell you, like in the problem below, what the photon energy is, and I tell you what the kinetic energy of the photoelectron is. And let's make up some numbers. Let's say that this is 7.2 times 10 to the minus 19 joules is your photon energy. Let's say that we tell you that this one is like 3.1 times 10 to the minus 19 joules. And then we turn around and we say, well, what's the threshold energy? How much energy does it take to pull an electron out? So this stuff will be embedded in a word problem. The word problem will look something like, you have a photon with energy 7.2 times 10 to the minus 19 joules, strikes a metal, ejecting an electron, or a photoelectron. I'm going to just say an electron, with kinetic energy 3.1 times 10 to the minus 19 joules. What's the threshold energy for the metal? This is pretty much exactly like the problem that you see below this. Now, look what I did. I took this basic information and I dressed it up this way. First thing you do when you look at a problem like this is think to yourself, what is going on here? I get a photon hitting a metal and it spits out an electron. Now what you should think is, oh, that's the photoelectric effect that they're talking about. I need to do an energy budget for the photoelectric effect. That's the key to the problem. So it is kind of important that they tell you that you've got a metal that's ejecting electrons involved here so that you can recognize that this is what you're going to do. And now I'm going to say, well, what do I need to know? I don't know this. They give me this and they give me this. It's pretty simple, right? All you got to do is take this minus this, and that will be the threshold energy. In other words, you're going to solve the equation for the threshold energy. E threshold is equal to E photon minus E photoelectron. And I know these two numbers. 7.2 times 10 to the minus 19 joules minus 3.1 times 10 to the minus 19 joules. So what's that going to be? 4.1, right? Times 10 to the minus 19 joules. That's how you do the problem that is right below this.